Hey, hello, and welcome to Show and Tell. We are here in Adafruit West in my workshop, but pretty soon we're going to be going to some people out there in the world to show us some of the projects they're working on, some they finished, some that they are thinking of starting. So what we'll do is I'm going to head first to Jane. So let's bring on Jane. Hello, Jane. Can you hear us?
Hello. How are you?
Doing great, thank you. Thanks for coming. I see that you've got...
yeah, thank you for having me.
You've got the Pee Wee Herman background, which is excellent.
Yes, my house, you know.
I'm jealous. What I'm going to do is I think you have something... Do you want to describe what you want to show us? And I'll bring up a second screen so everyone can see.
Yeah, so I got interested in learning Morse code a couple weeks ago. And one day I got the idea to make a Morse code transcriber. And the idea is that this is a device called an M5 stack. It's Arduino based. And it just has this one button in the center. So I programmed it using the Arduino language so that you can just press the button in accordance with Morse code to type out letters and spell things.
That's really cool. So you're able to do dots and dashes in Morse code pattern, and then it'll decode it and then put it on the screen?
Yeah, that's right. And the idea is possibly in the future I could upgrade it, I guess, so that maybe if there were two devices, they could communicate with each other and send messages. And then, you could secretly send messages in your pocket without having to see what you're writing or typing.
Oh, that's really cool. So how do you like this M5 stack? You've come from Arduino with other boards before?
Yeah, M5 stack, so M5 stack is a different board, I guess, that's the same idea. It's a bit larger and has 3 buttons, and then the same company made this board, which they call the M5 stick because of its small design. And both boards, I've been really happy with them. I'm having a few issues with this one where it does just turn off sometimes when I do a dash, but I'm not sure if that's my code's fault or the hardware's fault, so I'll have to look into that more. Overall, I think they're really good devices because of their size, and they have a lot of sensors built in on them and ports where you can add more stuff. So I think it's a really good device, and they're not that expensive. I believe you can get one for maybe like $10. So they're really good.
Oh, that's great. And the screen is built in, or is it plug in into?
It's built in, but I know you can remove the back, and I believe it's possible to do some modifications.
Really fun. Well, that's cool. And have you got any plans for your newfound Morse code skills?
I'm gonna need to find a friend to also learn Morse code so we can start a secret club. But until then, I'm just gonna keep learning.
Very cool. Well, thanks for showing that off. Great job with that. And when we are shipping things again, we will send you a as seen on Show and Tell sticker that you can add to your collection or put it on the side of there if you want.
Thanks so much, John.
Thank you. Bye-bye.
Bye-bye.
All right, that was super cool. Let's see, next we're gonna bring up Okiron or Okiron. Hello.
You're on.
Okay, you're on. Oh, okay.
It's my last name backwards, so that makes things fun.
That's very convenient.
Is my sound okay? I don't have a good mic.
Great. Here. Yeah. Looks like you're at a workstation here. What do you?
Well, that's the big soldering station. It's on a cart, so I can roll it around the studio here. So I've got some Trellis grid fun that I've been working on for a while. So this is what is it? 8 Trellis boards all together, and made a fancy enclosure with that to get it super flat and skinny. The bigger version back here, this is a 256 buttons. So big version. I have this one opened up, and it can kind of zoom in here. I've got a teensy go into a USB breakout to drive all that. And then the fancier bit still is to make that wiring a little easier. I made this flexible PCB carrier for the breakout and the teensy. So that gets it super, super flat for the enclosure. And then I can kind of show you that lines up on the Trellis board. Got a spare one here. So that kind of flops on there and then solders in place. Let's get it over here. So that'll kind of sit on top of all that and then just solder it into the connectors over here on the edge.
That is incredibly cool. So can you describe a little bit what you're using this for? What's it triggering?
So this is designed to be a Monome grid clone. So Monome has been making grids for 20 years, I guess, or maybe 10 or 15 years. And it's used for musical devices, and they're sort of just whatever the application wants to be will define what the grid does. So the Monome grids are just single color. So this one, you could set it to whatever color you want, but it's just going to be a single color while it's in that mode.
Very cool. Whoops, I don't know the controls here, so I'm doing funny things. let's go to side-by-side people, like that. Maybe like
this. They come back over here.
So are you able to put different code on these depending on if you want to send out like MIDI or OSC, or is it a serial communication that's to the Monome? Yeah,
absolutely. The Monome uses a serial communication that they designed. So what I've done is not reverse engineered it necessarily, but taken their open source protocol and adapted that for the teensy. Can also get it working on an M4 or M0. I've tried it on a Feather and an Itsy Bitsy, but that requires some extra hacking on the USB stack. But yeah, you could totally reprogram this to be the same as the what Adafruit has, the 64 Feather, and use it as a MIDI controller with RGB, or pretty much anything you want it to be. It's just redo the code however you like.
The case is pretty elegant. Is that a 3D printed or laser cut?
So laser cut. Let me see if I can get the kind of up here. So there's stacks of acrylic and some EVA foam, and I could probably run over and grab one of the other big pieces here. Give me 10 seconds. Quit that back. So here's the 256 layer that goes beneath the PCBs. So that's just all fancy laser cut. Get my headset back here, sorry.
And someone was asking in the chat, how is the EVA foam helping the...
That's a kind of a weird little hack that I did. I've got a stack problem that I want the height to be a very specific height, and EVA comes in a 5mm. Otherwise, acrylic is only either 3mm or 1.5. So it gets a little weird to stack things. And I was trying to find something that was like in that good height, and the EVA works pretty well for that.
That's cool. Yeah, nice solution. Great. Well, awesome build. I hope you can come on sometime with them lit up and making music or showing grids. I don't know if you have anything set up today that we can look at. Or
I was kind of like, hey, I could probably do this, and getting everything ready at the last minute. So
good. Okay.
I'd have to flip it all around.
Yeah, we'll have you on again to show it in action if you're interested.
Right on, right on.
Thank you. Very cool build.
Thanks, John.
All right. Now let's move on to Scott. Hello, Scott, and hello, Scott's screen.
Hello. I think I found the key, the window I wanted.
Nice.
So last week when I was on, I showed the two keyboards, the really small one and the really big one, and I was kind of debating how I wanted to hack into them. And I came up with this idea last week, and I think I mentioned it to you over our internal Slack, but I thought I would show it off. And I'm calling it the, I think, flip dip or dip flip. I can't remember which way I put it. Looks like it's flip dip. So this is what I'm calling the flip dip 24. And the idea is that I can take the 24-pin dip chip on that small keyboard, desolder it, put a socket down, and then I can put this PCB into the socket. And then I put the dip that I took out and put it onto that PCB underneath, and then I can have access along the sides to all the pins there. So I I have a DigiKey cart open where I have like a bunch of jumpers. So I'll just jumper all the way down until I want to like play around with some of the signals and being an intermediary.
Oh, that's cool.
So I designed it in KiCad and I ordered it from Osh Park last night. Trying to put like nice descriptions with like the chip doesn't go here, it goes on the other side. So if I rotate it around. Yeah. So what you see here is these pins here will go into the socket on the existing PCB. And then the existing dip will then go into this socket here. And so I call it flip dip because I take the chip and I basically flip it upside down. So the PCB's just the lines crossing over to flip the other sides.
And so besides jumpering it, are you able to then redirect pins to other chips to process?
Right. So
like Python?
Right. So these two, there's dual headers on the outside here because that's an intermediary. So from the PCB, the existing PCB, it goes to one side, one row of this connector. And then to connect to the actual chip, it has to connect to the other pin. So I'll be able to just use regular jumpers if I just want them to be directly connected, or I can actually like break it out onto a breadboard and like do something else or prototype other stuff there as well.
Cool. And that's going to be like the voice chip on your little synths, your Yamaha synths.
Yeah, particularly interested in the dip chips that do the keyboard scanning.
Oh, okay.
So we were talking a little bit about it on your matrix, but you have it nice where you just have a connector that is like all of the rows and keys for the connector, whereas that small one is it's a single PCB, and so what I've got to do is like I was thinking I could cut traces and stuff, and I was like, that's not a great solution. Like soldering to traces is doable, but it's not super fun. And so the nice thing about this is that once I take that dip chip off and put a socket on, I can actually put the chip right back into the socket and it'll work just fine as well. So this seems like one step into what I was doing rather than trying to do it all at once.
Yeah, very cool. So it could also be a way to deal with circuit bending stuff without cutting.
Yeah, just with desoldering. Yeah, so this is kind of an idea I have. In my cart, I actually have 3 different dip sizes of sockets that I found because I was looking at some of the other keyboards I have where the 470 that I showed has 2 different dip chips. It has one for the sound chip, and then it also has one for like the main CPU that does the keyboard scan and controls and stuff. So I have sockets for that, and I'll probably make the equivalents of this for that as well. But this is the first one I did, and I ordered it just to get it going. But
good. Yeah, that'll be fun. It's like the present that keeps on giving because you get things in the mail like a couple of weeks later and you've forgotten about them. So.
Yeah, I like to pipeline things. So
good.
So it's all good.
Excellent. Well, thanks for showing that. We're looking forward to seeing the progress with that.
Yeah, cool.
All right. Thanks.
Thank you.
Bye. Okay. Well, next we're going to go to Geek Mom Projects. Hello.
Hi, how are you?
Doing great. Thanks. How are you doing this day?
I'm doing pretty well. I'm starting to get the hang of this show and tell thing. I'm going to see if I can switch to my other microphone to actually show camera to show what I have been working on.
Terrific.
As usual, let me see if this works. I'm all wearables all the time, usually LED based. So, it works. Can you see that?
Very nice. Yeah.
So, and as many other people have been doing, I've been sewing masks. So I started, been doing a lot of masks and a lot of LEDs, and I started the week by actually creating a pendant using an Adafruit dot star, those little teeny 8x8 2020 matrix, and I made it sound reactive. I don't have a good battery hooked up. Oh, there you go. Don't have a good battery hooked up, but I'm going to move my voice close to it so you can see the sound scrolling by. And it's basically a MEMS microphone hooked up to a trinket, hooked up to an 8x8 dot star array, and it shows. You have to speak kind of close to it for the sensitivity to work, but it shows the sound scrolling by. So I started with that, and then I'm like, well, I'm sewing a lot of masks. How can we put LEDs in masks? So I actually had another microphone, and I put it in a. I'm gonna be quiet for a second while I turn it on because it needs to initialize quietly. Sometimes it needs a second restart. There we go. Okay. So then I took basically I took the trinket and the microphone and I hooked it up to a circle of LEDs, which are now not behaving, of course. And then I realized, and then you could put it inside the mask for a sound reactive mask. And then someone pointed out, well, what you've done would actually be a lot easier with the Circuit Playground Express. And I said, yeah, you know what? I've kind of reinvented the Circuit Playground Express. So let's switch to that. So as it turns out, it's much easier, and the code is written for you if you take the sound reactive code for a Circuit Playground Express, turn it on, and then all you actually have to do is, if you have a mask with a pocket, as so many people do, you can actually just slip it right in, and which I'm going to do. And then I'm going to switch the camera back and actually demo. So you just slide it right in the center there, little battery. And let me turn the camera back to me.
I love the journey of your iterations that you've gone through here on this, all in what, like a day?
Yeah, no, it's true. Well, it was quite a moment when I realized I just basically recreated CPX.
This thing is great.
Somebody should invent this. I'm like,
absolutely.
But then you take your mask, and I'm going to move the headphones off for a second. Oh, it's a little hard to, the lighting makes it hard to see. Here, let me get into a third angle. So voila, sound reactive mask. It's better if you take the time to put it in just the right place. But it's kind of a fun little easy hack to do. And there we go.
That's really cool looking.
That's fun. And actually my next goal, yeah, it's better when you have it in the right place and don't do this like trying to figure out how to reverse it while you're looking at a camera. But yeah, it works. And then I thought my next step would be to take this and switch to the Adafruit Express and actually try to like have the sound coordinated from here and use another Bluetooth item and like have like my bag coordinated with my face.
Oh, neat.
So that's where I'm headed with that.
That's very cool.
And it's a small hack. It's fun.
That so did you do that one in Circuit Python or MakeCode?
All Circuit Python. Actually, this code is literally nothing more than the example. But yeah, I'm working with the Bluefruit Circuit Python app to try to actually coordinate. It wasn't working quite in time for this demo, but I wanted to use the clue board in one of my Bright Wearables bags and actually have my bag coordinate with my
cool. Yeah, good. We'll bring that on to one of the show and tells next week if you have something ready. We'd love to see it. Thank you for sharing. That was way cool. We'll see you later. All right, so many good projects. Let's see. Next up, we have Dr. Footleg. Hello.
Can you hear me?
I can hear you very well. Thank you for coming by today.
So I thought I would bring my Mars rover robot to show today. So this is something I designed for the Pi Wars robotics competition in 2019, based on the NASA Curiosity rover rocket bogie suspension. So the two sides of the six-wheel design kind of hinged with this rocket bogie arm across the top. And that means the design of this type of suspension is such that all six drive wheels should be able to stay in contact with uneven terrain at all times. So this was cut down to the size of a footprint of a sheet of A4 paper in the UK terms. That's similar to your 8.5 standard paper size in the US, with servos to make all of the four corner legs steer, and then some LED display matrices on the top, these little Pomeroni ones. There's a Pixie camera built in the color sensing and for general camera work. And then on the top, a touchscreen where I can control the menus or display any kind of output on the top.
That's a really cool build. What is the what are you using to drive it as far as microcontroller and also like motor drivers or servo drivers?
I'm glad you asked, because that neatly segues into the next part of what I wanted to show. So one of the challenges here was that the touchscreen on the top, when I looked up what GPIO pins it uses to see what was left over for kind of running my motor driver hardware and servos, turns out it uses every single one of them. And the only thing that it makes available is the software I2C bus. So that's broken out. So I had to use all hardware that was I2C supporting. So I started actually with one of the Adafruit 16-channel servo breakout boards, and I used the PWM channels on that to drive the motor driver breakouts, which are also a couple of the little Adafruit ones that'll drive up to about 3.6 amps, because I've got 6 motors in total to drive. So I needed a sort of higher current than your typical motor drivers that you'd use with these little micro metal gear motors that you see on the bottom. Now the problem with that is that I don't know how clearly you can see on the camera there, but the interior ended up absolutely stuffed with wires, to the point that the original design was that you would be able to slide out the Raspberry Pi hardware on this kind of cartridge and access the cables to do any kind of maintenance or to show what the interior was like. But it's so rammed with wires that it became impossible to open up the case in a hurry. It takes about 20 minutes of fiddling around with a screwdriver to try and kind of stop them getting snagged. And so after the competition, I decided that it would be a great PCB design project, which was something I wanted to learn, to make my first Raspberry Pi hat. And this is where the open source hardware that Adafruit publish and make kind of available to the community has been an absolute godsend, because it's really accelerated the speed I could learn about the PCB layout and surface mount kind of components, and sort of how to put the hardware, because it was all based on Adafruit breakout boards. I started working on a hat and trying to combine all of that into one board. So you can see here the board which is planned to go inside the robot, and it solves a couple of problems that the robot had, apart from combining all that hardware into a more compact form factor. One was that I had no available I/O pins for adding additional sensors that weren't on the I2C bus. So I managed to fit onto this board one of the 16 digital I/O ICs, which is this one here, alongside the 16-channel PWM IC. So that's given me 16 additional digital I/Os to play with. And the other problem I had in the robot was that to get the ribbon cable from the Raspberry Pi header, which is kind of on this plane, to this angle to go into the display, I actually had to fold it over on itself about 3 times. So it kind of folded, if you imagine, it starts like that, then folds like that, and then 45 degrees. So that sandwich of ribbon cable really was one of the things which is kind of cramming the interior. You can often see it kind of folded back on itself and over on itself in the back there. So the hat also, I've got another build of it here with the actual headers soldered on another little robot where I'm testing it. There's a second Raspberry Pi GPIO header that's rotated the appropriate way, orientation, for the ribbon cable to just be a straightforward kind of up to the display. So the entire
that's a nice thing to solve.
Yeah.
Very cool. Yeah, that's a pretty familiar thing, right? Once you get the thing built, the amount of cabling and interconnects is the biggest pain. So it's nice to see that you've taken matters into your own hands to create the PCB for the hat to solve a whole bunch of that wiring nonsense you end up with. Yeah,
so and it's been a fantastic learning project, which the resources of the Adafruit website have really accelerated the speed I could learn. It all started with a tutorial on KiCad that was in Hackspace magazine. and quickly got out of control as I
Good, I can tell.
more and more into this PCB. And
that's fantastic. Yeah, no, we're looking forward to seeing it in action as you get it put together, and maybe you'll share if you have a link, if you're sharing the file, the board design, or any of that stuff for other people at some point.
Yeah, I'll eventually, when I've kind of tested it to the point that I'm happy it's functional, because I'm a strong believer in open source, the project's built on open source, but I don't want to publish before it's actually fit for purpose. Not because I don't want people to have access to the design, but there's nothing worse than picking up a project that turns out to have all of the pitfalls and wrinkles. And
Right.
I'm acutely aware that I've kind of been learning PCB design. This is my first real project in that area, and also surface mount soldering. And so I'm already on my second revision of the board, because the first one I ordered with footprints that turned out to be the wrong size for the resistor arrays I bought.
Yeah.
I've been warned away from the really teeny tiny resistor arrays, so I went for a larger size, but it turned out that the sizing is not as straightforward as it appears, and the sizing names of the footprints in KiCad didn't match the actual sizes of the components. So I had a set of boards, you possibly can see on this one that if I can get it close enough to the camera, that where there should be a bunch of resistor arrays, there's actually all of these are resistors mounted on their edges, and then there's a crazy kind of Stonehenge of resistors on the top near the jumpers there, because I had to kind of fit that around the kind of footprint which I had when I couldn't get the arrays to fit. So a lot learned, and
Good. Well, thank you. Yeah, we'll be looking forward to seeing your continued learnings on that, and see you on a future show and tell. And I have, I think, 2 other people we're going to go to. So we'll say goodbye to Dr. Footleg.
goodbye. It's been a pleasure.
Let's meet up with Curtis here. Hello, Curtis. I'm not hearing you. Let's see if I can unmute you.
That was me, sorry.
There you go. Welcome.
Thank you. So what I've built is a Circuit Playground Express Thunder and Lightning engine for my mom's miniature dollhouses. You can place this outside the dollhouse windows, and it creates some thunder and lightning. I did it in CircuitPython. I'll just do a quick demo. It's a randomized time and a randomized sound effect from 3 different sound effects. So it doesn't sound too mechanical and too robotic. And it's amazing. I'm not much of a programmer, but CircuitPython allowed me to create this with not much trouble at all.
That is terrific. And so that's going to go inside of a dollhouse to do the lighting from inside?
Yeah, outside her windows or inside a dollhouse, wherever it kind of makes sense to have that flash kind of.
That's cool. That's really great. Very nicely done. Like I said before, we are not shipping things out right now other than COVID-19 related things and PPE, but in the future when we're shipping again, we'll have you get in touch with us and send you a As Seen on Show and Tell sticker if your mom wants to add that to the dollhouse as a poster or something like that.
Thank you.
Great. Very nice build. Thanks for sharing that. We'll hope to see you again sometime.
Thank you.
All right. And I think we'll be checking in with our last person here. We have Jeff Epler. Hello, Jeff.
Hello. It's good to see you, John.
Nice to see you too.
So today I'm showing a little thing that I just put together. It is a little 3-key keyboard made out of Lego. So Adafruit sells this little guy. You put any Arduino style board in it, and I've wired it inside to 3 cherry keys that are on a custom printed 3D Lego plate. And you know, there's a tree, because why not a tree? And right now what I have the software doing when I plug it in, it runs with CircuitPython, is this button and this button work as the mouse wheel, and this works as the middle button of the mouse, because on my laptop I can't easily access those functions. So I don't know if this is convenient enough to sit by my laptop and actually have me use it, but I'm going to give it a try for that. And if not, with CircuitPython, I can repurpose it to do
really cool.
something else tomorrow.
That's a fun build. So how are the keys mounted? Is there a little PCB?
Yeah, let me pop that off.
Sorry to
Just
make you
give me a
open
second here. No, it's no problem at all. So they are directly mounted to this custom 3D printed Lego piece. So the gray piece is a 3D print that has cut out for 3 Cherry MX style switches. And then it just mates onto other Lego pieces to go into the final product. And it took me about 3 or 4 tries to get the fit right on my 3D printer to fit with Lego, but it works. And I would definitely do it again for another new project.
Were you playing with the stuff like wall expansion on your sizes?
Right. Yeah. On Thingiverse, there are some great customizers for making Lego pieces, but you still have to dial it in for your printer. And so in my case, like you can mess with the extrusion width, set that a little lower, and horizontal expansion and those things. Just give it a couple tries and eventually it'll work.
Did you say, are you printing in ABS to?
No, this is a PLA Plus style material. So, it gets some of those benefits of the other materials. It worked. It was just what was loaded and what's easy. So there's not going to be a lot of insertion and removal cycles. I figure it'll probably be okay. But really I might consider ABS if I do have to reprint it in the future.
Mm-hmm. Well, I've been lurking on the subreddit R mechanical keyboards lately, and I'm sure that the people there would love to see your creation if you dare to post it.
I'll think about it. I don't do Reddit much, but yeah.
Right. Very cool. Thank you so much, Jeff, for stopping by and showing that. I love it.
It's fun to be on.
All right. I think that is almost all, but Techniac, who was having some technical difficulties, I think may be back. So let's see if we can.
Hey, can you hear me okay?
Yes, we do.
All right. My camera was causing StreamYard to crash, so you're going to look at my website instead. So I run a group called Hack the Pandemic, which is helping to coordinate a lot of the PPE logistics stuff on the New York, Long Island, that area, and we're now expanding up and down the East Coast. But one of the big things we wanted to talk about, and I'll see if I was smart and put a photo actually on our website. It's not working. And now my website's crashing. Oh boy. Is the 3D Verkston shield design that has been circulating in the community for the past couple of days. You can see printing there. We're actually working on a giant injection molding run on it of looking at 20,000 units a week. And again, I was going to show off all of our prototypes, but my camera's not working, so I'll talk about it. But our big thing right now is getting that geared up and sort of trying to ask the Adafruit community if anybody is has either printers that aren't printing something, which I kind of doubt right now, or has access to industrial size laser cutters or die cutters, because the front shield material obviously can't be injection molded, and so we need people who are able to produce that, as well as if you happen to know anybody who has a couple 100 pounds of the filament lying around for our 2 print farms, that helps as well. But I'll put some photos up in the live broadcast chat on Discord with our prototypes.
Yeah, and put some links there to the site so people can
definitely
click on that to go if anyone can help out. Thank you for doing that. That's really terrific.
Yeah, anytime.
I'll coordinate that effort. 20,000 a week, you said?
That's our goal. We're starting with one run of 20,000, and then we should be able to continue at about 20,000 a week.
That's fantastic.
From there. So.
And are you working with a local tooling company to build?
Protolabs.
Okay.
We have a couple contacts at Protolabs who've been helping us with some stuff. We'd like to start working with a tooling company. So if anybody knows of anyone in the New York City area who is willing to help us out, everybody we reached out to is either already producing or shut down.
Mm-hmm.
But we have the ability to get people essential business paperwork if need be. So.
And I'm curious, when you're injection molding, is there an ideal plastic material for this type of use that you're targeting?
there's a whole bunch of different plastics you can do this in. In our case, we're probably going to be doing it in polypropylene because it has the high temperature resistance, meaning that it's able to be autoclaved multiple times.
Mm-hmm.
So we're hoping that we're able to injection mold for like 3 weeks, and then the hospitals will just have enough stuff for them to be able to start autoclaving
Mm-hmm.
and not having to keep producing infinite supply
Mm-hmm.
to go in. But the only disposable part would be the Petchy front shield component.
Mm-hmm.
And we're using the Prusa matched 3D Verk design.
Mm-hmm.
So our supplier who already has Prusa shields going is able to do that.
I see. Good. Well, good luck in finding hopefully some people to help with that effort, and we appreciate what you're doing.
Yeah, thank you very much.
All right. Well, we'll say goodbye for now, and I'll thank everyone who stopped by for this mini show and tell. Not so mini. We went a good half hour, I think. And please, if you have things to show, stop by next week. We'll be doing another show and tell on Wednesday night, and this one on Thursday after my workshop show. So with that, I'll sign off. Thank you so much, and we'll see you next time.